So what's the meaning of an earthquake? The earthquake is a sudden movement, حركة مفاجئة, or vibration of the ground. So suddenly some people feel that the ground vibrates or the ground shakes. It occurs when large rocks in the crust of the earth or under the crust of the earth suddenly slip because of the overstress or the stresses over the rock. The rock will break, forming a crack. This crack, we call it the faults. And these rocks slip, and when they slip, they produce a big amount of kinetic energy. This kinetic energy is in the form of vibration. And this vibration transfers from a certain place to the other, causing this vibration to the ground, which we call the earthquake. 95% of all the earthquakes occur along the plate boundaries. Most of the earthquakes occur along the plate boundaries. Do you remember when we said there are three kinds of boundaries? The divergent boundary, the transform boundary, and the convergent boundary. So if you look at this map, this is the map of some earthquakes in 1 year. Okay, these are the big earthquakes, not all of them. These are the big earthquakes in a certain year. And if you look, for example, in this area, do you remember what's the name of this area? It's the MOR, the Mid-Ocean Ridge. So the Mid-Ocean Ridge, the line of the Mid-Ocean Ridge has a lot of earthquakes, as you see it here. Also this line, do you remember what was this? So that's called the subduction zone. Subduction zone is when the oceanic plate moves under the continental plate. So the oceanic plate here, it moves under, it goes under the continental plate. And as you see, it's full of earthquakes. The same here also in the transform boundary or the other convergent boundary. Okay, it's full of earthquakes. So if we can trace the earthquakes during the year, we can draw a map for the boundaries of a certain plate. Like this is the African plate. African plate. How do you know that this is African plate? I just followed the locations of the earthquakes around Africa. Okay. So this one, that's called the Nazca plate. The Nazca plate is the plate goes under the South American plate. It goes beneath the South American plate. There is the big one here, this one. This one is called the Pacific plate. And by the way, this line, it has a name. It has a famous name. This line here, until here, they call it Ring of Fire. Ring of Fire. حلقة النار أو حزام النار. Because it's full of volcanoes and earthquakes. So the Ring of Fire is this line around the Pacific Ocean, which is full of earthquakes and volcanoes. Several millions of earthquakes occur every year. But alhamdulillah, majority of them, they have very low amplitude. 97% we cannot feel them because they have very small amplitude or magnitude. Okay, adding to that, most of them also happen inside the ocean. They happen inside the ocean, so we also don't feel most of them. Okay.
دكتور.
Yes.
الموجات الزلزالية اللي تكون تحت 5 ريختر ما نحس فيها صح؟
No, we can feel the 5, we can feel the 4, we can feel the 3. Okay, but it depends on if the source is near your location, so you will feel it. But if it is far from you, you will not feel it. So the more the distance between you and the location or the focus, as we are going to talk about it, of the earthquake, the weaker the earthquake is. The depth of the earthquake. The depth of the earthquake. Earthquakes that occur along divergent boundary or transform boundary, divergent boundary like the MOR, transform boundary like the boundary in California, the San Andreas fault, around this San Andreas fault, that's a transform boundary. These earthquakes are shallow earthquakes. Shallow means it's not deep in the crust. It's shallow. Usually, the earthquake occurs at a depth around 10 to 15 kilometer. So at a depth 10 to 15 kilometer, most of these earthquakes happen. So usually in general, its depth is less than 70 kilometers. If the earthquake occurs at a convergent plate boundary, like a subduction zone, for example, okay, so in this case, it has a great depth more than 70 kilometers. More than 70 kilometers. Sometimes 100 kilometers, 200 kilometers, 400 kilometers under the ground. So these earthquakes might happen in the lower part of the crust or in the next layer under the crust, which is the upper part of the mantle. If you remember, we said there is a layer called the lithosphere. The lithosphere has the crust at the top and the upper part of the mantle at the bottom. Okay? So these earthquakes, which happen at the convergent plate boundary, usually it happens in the next layer under the crust. Usually. Okay? The next layer under the crust. There is a live map here for the earthquakes. Okay? It's a website called the United States Geological Survey, USGS, and it provides a live map for the earthquakes. So you can see the earthquakes that happen today. So that's today for earthquakes with magnitude 2.5 or more. Okay, this earthquake here, this one in Turkey, it happened today in the morning. It happened today during the morning lecture. Okay, it's at depth what? 10 kilometers. Okay, this one is at depth 10 kilometers. This one at depth 10 kilometers. If we go to California, 8.6 kilometers. So it's at a transform boundary. But if we go to a subduction zone like South America, like this one, 73 kilometers. This one, what happened? 124 kilometers. Okay, so on the subduction zone, 134 kilometers. On the subduction zone, the depth of the earthquake is much higher than the other one. Not all of them, but most of them. Okay, you can see the location and you can see the depth from this map. This map can show you up to, if you want, all the earthquakes in the year. Like let's say, let's take 30 days, the last 30 days. Okay, so when it loads, you will see a lot of earthquakes everywhere on the map. It starts to show you now. And as you see, if we trace these earthquakes, it tells us what is the boundary of the plate. So if we go to this ring of fire, it tells us boundaries of the Pacific plate. Okay, here also, what's the boundaries of African plate? But maybe we need more time. Let's take like 1 year or something like that. Okay, so you can refer to this map if you want to look at the earthquakes that are happening. What are the reasons of the earthquakes? Reasons of earthquakes. Inside the earth, if this is the surface of the earth, these are layers. We said this is the crust, for example. This is the upper part of the mantle. This is the next part of the mantle, and so on. So these all layers are rocks. But the rocks at the top, like the rocks of mountains, the rocks of the top part of the crust, like let's say the first 5 kilometers of the crust or the first 3 kilometers of the crust, they are rigid rocks. Rigid rocks. So rigid صلب. But when you go deep in the crust, the rocks in this area, or the rocks in the mantle, or maybe the upper part of the mantle, or the next layer, the asthenosphere, they are elastic rocks. Elastic rocks. So they are not rigid rocks like the normal rocks that we have on the surface of the earth. So the rocks down, they look like elastic rocks. What's the meaning of elastic rocks? صخور مرنة. صخور مرنة. So if we apply some certain force on the rock, like some forces from both sides here, when we apply this kind of force, we call it stress. We apply a stress, إجهاد. In mechanics or in metallurgy, we call it stress. So we apply a stress over the rocks. Okay, you try to compress the rocks. Because the rocks are elastic. And why are they elastic? Because the high temperature and the high pressure. The high temperature and pressure in the deep crust or in the upper part of the mantle, they become a little bit elastic. So some deformation will happen to the rock. Some kind of deformation will happen to the rock like this. When the rock deforms, this is what we call it elastic deformation. Elastic deformation. التشوه المرن. It's similar to what? If you have a ball and you compress the ball will deform. Or if you have a spring and you compress the spring will deform. Okay? And both are elastic objects. So what will happen when they deform? Something that we have studied in physics before. Do you know what's going to happen when the object elastically deforms? It will store kind of potential energy. It stores some kind of potential energy. Even if you compress it or you try to stretch it. If you stretch it, also the same. So it will deform like this, and also it saves potential energy. So the potential energy in the rocks, we call it strain energy. Strain energy. Okay, that's something that you will study in metallurgy if you study engineering, especially mechanical engineering or petroleum engineering and some others. You will study in the metallurgy what is the strain energy and the stress over the objects. So this potential energy is a strain energy. It's energy saved in this object, exactly like the spring. If you release the force, it will return back to what it was. But here the force is continuous. The force does not decrease, but the force increases. So the stress over the object, over the rock, increases. So what will happen at the end? Will it continue to save energy and to store energy forever? Or at a certain moment, something will happen to this rock? So a crack, شق, will start in the middle of the rock or somewhere in the rock, and then it extends to the other parts of the rock. So we expect that there will be a crack in the rock. So you apply stress because of the forces under the ground. Forces are trying to compress or stretch the rocks. So the rocks, they try to handle this stress, but at a certain moment it cannot continue. It must crack at a certain moment. So when the crack starts, the rock slips. تنزلق. The rocks will slip. Slips like what? Let's see. This right part will move like that. And the other part will move like that. So this is how they slip. So part of them moves past to the other. And this issue happens in a moment. Might take a second or maybe less than that. So when this happens, we call it the elastic rebound. The elastic rebound, الارتداد المرن. This elastic rebound releases the stored energy. It releases the stored energy. What was the stored energy? It was a potential energy. We call it strain energy. It's restored as kinetic energy. It's normal. Okay. If there is a stored energy, it will return back to become kinetic energy. This kinetic energy is released as vibration. Vibration, اهتزاز. And this vibration transfers and spread in every direction in form of seismic waves. It spreads in every direction in form of seismic waves. موجات زلزالية. Okay, guys, do you have any question in this part? Huh? Do you understand the cause of the earthquake? So here I'm not talking about a small rock. I'm talking about a huge rock. It extends for several kilometers. The rock itself has a dimension as hundreds of meters at least, or several kilometers, or maybe more. So it saves a big amount of energy. I'm not talking about 100 joule or 1,000 joule or 100,000 joule. I'm talking about millions and billions of joules and maybe more. So these are some animations that show you the slip of the rocks in different boundaries. If we have a divergent boundary, at a certain moment, the crack will start. And by the way, the crack that happens, we usually call it the fault, الصدع. If we look at a convergent boundary, if we push from both sides, so that's a convergent boundary. As you see, at a certain moment also, there will be a crack and will slip. When it slips, the vibration starts. So also the third one, if there is a fault here or a crack and the rock slips, also it's accompanied by an earthquake. So you need to know what is the fault. The fault is the crack that happened in the rocks. And at this time when it happens, the rocks slip. And this slip releases energy, and we call it the elastic rebound. And when this happens, it produces kinetic energy, and this energy spreads in every direction as seismic waves. So you need to know what is the elastic rebound, what is the seismic wave, what is the meaning of a fault, what is the earthquake. Okay, let's see what are the seismic waves. الموجات الزلزالية. The seismic waves, they are induced because of the elastic rebound of the rocks when they slip along the crack or the fault. So these seismic waves, it starts from a certain point on the crack. This point, we call it the focus of the earthquake. The focus of the earthquake. بؤرة الزلزال. So this point is where all the vibration starts. The vibration starts to move in all directions. If we move directly above the focus, move directly above the focus until we reach to the surface of the earth. This point is called the epicenter of the earthquake. So what's the epicenter? Epicenter is a point on the surface of the earth, and it lies directly above the focus. We call it in Arabic المركز الظاهري للزلزال أو المركز السطحي للزلزال. So the point where the seismic waves starts is the focus. The point above it is the epicenter. What are the kinds of seismic waves? We have three kinds: primary waves, secondary waves, surface waves. So these waves are seismic waves. When the focus starts to produce this vibration, or it vibrates the rocks around it, and this vibration moves in all directions. These vibrations are the primary and the secondary waves. So the primary and secondary waves start from the focus. And when these waves reach to excuse me, when these waves reach to the surface of the earth, they will shake the surface of the earth. So the surface of the earth will vibrate. And this vibration also will transfer through the surface of the earth. And in this case, we call it surface wave. So what's the difference between the surface wave and the primary and secondary? Primary and secondary start from the focus. And they move inside the earth. They move inside the earth. While the surface waves are what? When the vibration reaches to the surface, these vibration will shake and will vibrate the surface, and it will spread through the surface of the earth. And we call it surface waves. Let's see what are the differences between the three kinds. Let's start by the primary waves. Let's say this point is the focus of the earthquake. This is where it lies along the crack. The vibration starts from here. So this focus will push the first layer of the rocks. It pushes the first layer of the rocks. So the first layer, by its turn, it will push the next layer. And the next layer will push the next layer. And so on. Each layer pushes and tries to compress the next layer. So if you look at this point, it's a point lies in the direction of the wave. You will find that it moves forth and back here, or we call it back and forth. So it's a kind of compressional wave. موجة تضاغطية. Each layer compresses the next layer. Like if you have some pieces of dominoes. If this one pushes this one, then this one will push the next one, and each one will push the one after that. So the vibration here moves through the domino pieces. So that's a kind of compressional wave. Why it moves back? Because that's a vibration. It's a vibration. Do you remember the pendulum? It moves back and forth, but at the end, it will have its equilibrium position in the middle. So that's what's happening. It moves back and forth multiple times, not one time. It starts to shake back and forth, back and forth, back and forth, until after some time it becomes stable. Okay? And this vibration moves from a layer to the next layer. So that's called the primary wave. What I need you to know is the wave moves in this direction. This is called the propagation direction. Take care of the name. Propagation direction. اتجاه الانتشار. The propagation direction. The vibration of any point, it's back and forth, and it's parallel to the propagation direction. The vibration direction is in the same direction or parallel to the propagation direction. So this is called compressional wave, and it's a kind of longitudinal wave. Longitudinal wave. Longitudinal wave. الموجات المستطيلة. I think you studied something like that in the high school. The longitudinal waves, الموجات المستطيلة. These P waves are the fastest seismic waves. They are the fast waves, fastest. It can reach a speed 7 kilometers per second. 7 kilometers per second. And they can travel through solids or liquids. They can travel through solids or liquids. What about the next one, the secondary wave? If the focus is here, the same exactly. The focus lies along the fault. The focus produces vibration. So this vibration also will vibrate the particles also up and down. It tries to push the layer, but also it vibrates the layers up and down. So the layers will move or transfer this vibration to the next layer like this, up and down, up and down, up and down. So it propagates and also it vibrates up and down. Okay? So here the direction of propagation, اتجاه الانتشار is this direction. But what about the direction of vibration? Look at the black dot and you will see the direction of vibration. It will be up and down. Have you seen it? So the direction of vibration is perpendicular to the direction of propagation. Direction of vibration اتجاه الاهتزاز. Direction of vibration. Direction of propagation اتجاه الانتشار. This is where the wave travels. Okay? So it shakes and moves, shakes and moves, shakes and moves. Because it's not moving in a straight line, it's not moving in a straight line like the P wave. The P wave was moving in a straight line. As you see, layer pushes the layer pushes the next layer pushes the next layer, and so on. So the vibration is in the same direction as the wave traveling, as the wave is traveling. So that's why it's very fast. While the S wave, the secondary wave, it needs to shake up and down and then move up and down. So each layer must be shaken up and down and then transfer this shaking to the next layer. Okay? And this transfer is vibration, it transferred through something we call it in engineering the shear stress. It's because of the friction in between the layers. Okay? So when a layer moves up and down, because of the friction, the other layer or the next layer will move up and down. And by its turn, the next layer will move up and down. So that's because of the attraction forces between the layers, the huge friction between the layers. So it can move through the layers. While the P wave, it's just push, push. So there is a difference between the motion of the P wave and the motion of the S wave. Both of them start from the focus, and both of them start together. But because they have different mechanism, the mechanism of motion of the P wave is different from the mechanism of motion of the S wave. S wave has to move up and down, up and down, up and down. That's why it moves slower than the P wave. So the S wave is slower than the P wave. The S wave is a kind of a transverse wave. Transverse wave is like the wave in the rope or in a string. Okay? Up and down, that's like a wave in a certain string. So the S wave is slower than the P wave. What else? The S wave can move through solids only. Solids only. It cannot move through liquid. Do you know why? We said it while we are discussing the motion of the wave. What about the liquid particles? If we consider these as layers, each layer in front of the other, each layer in front of the other. When this layer moves up and down, because of the friction and the attraction forces, the next layer also will move up and down. And because of friction and attraction forces between the particles, it will move up and down, up and down, up and down. But in the liquid, what about the friction in the liquid? It's almost very low. In the liquid, there is no friction, or the friction is very low. Okay? So the layers, the attraction forces between the layers of the liquid is very small force. So that's why this kind of vibration cannot move inside the liquid for a long time. The first one will vibrate, the second one will vibrate a little, the third one will vibrate a little, the fourth one will not vibrate at all, and so on. So it dies, or we call it damps. It damps تضمحل أو تختفي أو تتضاءل. The third one is the surface waves. When the waves reach to the surface, it starts to shake the surface. And this shaking spreads in every direction through the surface of the earth. This shaking also has two types. When it spreads, it shakes the surface in two ways. And both they happen together at the same time and in the same place. Okay? At the same time and same place. There is the side-to-side vibration. Side-to-side vibration. So the surface vibrates side to side like this. So if you look at the black point here, you will see that it moves side to side. Can you see that? So this is the first part of the surface wave, side to side. Also, when the wave moves, it tries to shake the surface up and down in a rolling motion like the ocean waves. If you have experienced it before, to go to the beach and stand in the water like this, if you go to Jeddah or go to Dammam or Khobar, and if you stand in the water, if there is a wave coming, when a wave comes, it takes you up and down and pushes you a little bit backward. Okay? So this is what's happening to the surface also. There are some up and down rolling motion that happen to the surface and moves from a certain part to the other. That's called the up and down rolling motion. So the surface wave has two components, the side to side and the rolling motion, or the up to down rolling motion. The seismologist who discovered the up and down rolling motion was Rayleigh. So it's named after him, Rayleigh wave. He was a seismologist, Alim Zalazil. Other one, the side to side, it was discovered by Love. That's the name. That's a name of the scientist or the seismologist. So we can call it Love wave. Okay. So we have the side to side and the rolling, up and down rolling. So which part of them causes most of the destruction? Which part causes most of the destruction? The side to side. The side to side causes most of the destruction to the buildings and to the power lines and bridges and all of that. The earthquake measurement. We have a device called the seismograph. This seismograph senses the vibration and gives us a chart that has the vibration of the earthquake. So if we have an earthquake happens at point A, and there is a station here, seismic station, that has this device. We said the waves move through the earth and on the surface. Which wave will reach first to the station? The P wave or the S wave or the surface wave? The P wave, because it's the fastest. So it will draw the P wave. Then after some time, the S wave will come after that. Then after some time, the surface wave will come after that. Okay? So the P wave is the fastest. Then the S wave after that, then the surface wave comes after them. Okay? How to determine the magnitude of the earthquake? We have two scales. Richter scale, مقياس Richter. They take, after they measure the amplitude or the magnitude of the earthquake, they take the logarithm of this number. They take the log of 10 to this number and put it on a scale. So if it is 100, the log scale is 2. If it is 1,000, log scale is 3. If it is 1,000,000, it will be 6, and so on. I think you have studied the logarithm before. So we have a scale starting from above 0 up to, I think, 10. Okay? So, for example, there are 3 million earthquakes below 2. So 1.3 million earthquakes below 3, and they are potentially felt. 130,000 below 4, it's felt by some people. 13,000 earthquakes below 5, and it's felt by most of people. Okay, around 1,000 or more every year are damaging. That's below 6, and so on. If it is above 8, it will inflict major damage. And there are around 17 earthquakes, but not all of them happen in cities. Okay, maybe some of them might happen in an ocean or at a certain island or away from the communities. So this is Richter scale. So in the news, when you hear about, if you hear about an earthquake, they tell you the magnitude in Richter scale. But when they discuss the consequences of the earthquake, we need to talk about Mercalli scale. Mercalli scale are 12 levels. They tell you about the consequences and the effects of each earthquake. So for example, number 9 here. There will be, if it is 9 on Mercalli scale, there will be a general panic, great damage of the buildings. Some houses thrown off foundations, الأساسات. The underground pipes broken, the water pipes and the gas pipes, the stores might suffer some break or like that. Serious ground cracks, there will be cracks in the ground. So Mercalli scale takes into account many things other than the magnitude. It takes into account the magnitude, the place of the earthquake, the time of the earthquake, the community that live near the earthquake, and so on. To sense the earthquakes, there are some seismic stations, and they are distributed all over the world. Okay, there is a network called the Global Seismographic Network that have sensors, and they are distributed in the continents, in the oceans, and they are communicating through satellites and internet. One of them lies here in Saudi Arabia. So if you look at the map, one station or one sensor here in the middle of Saudi Arabia. How to locate the epicenter of the earthquake? To locate the epicenter of the earthquake, we need 3 stations. We need 3 stations at least. Each station will sense the vibration. So they will make a chart, the P wave first, and after some silence, the S wave, and after that, the surface wave. Between the P wave and the S wave, the time is called the lag time, وقت التأخير. The more the distance between the epicenter and the station, the more the lag time. So let's say the lag time is 6 minutes. They take this chart and go to another chart that has a relation between the distance from the epicenter in kilometer and the lag time in minutes. Of course, this is an old method. This is an old method that they used to use it hundreds of years ago. But now everything is computerized and they give you live results. The results at the time of the earthquake. That's why we can see earthquakes maybe few seconds after it happened. We can see it on the map as I show you like minutes ago. So they take it here and they lie this chart on the graph and they measure 6 minutes. So 6 minutes between those 2 points, they see the corresponding distance, around 4,500 kilometers. So the station, let's say it's station 3, will say, okay, the distance between us and the earthquake is 4,500. But in which direction? Maybe this direction, maybe this one, maybe this one, maybe this one, maybe this one. We don't know. So we will draw a circle with a radius 4,500 around our place. Okay? Then the next station will do something similar. Station number 2 will measure the lag time. So let's say they will measure 4 minutes. They will go to the chart and they will search for 4 minutes. This is 4 minutes. 1, 2, 3, 4. Okay? Then they will look at the corresponding distance. 2,500 kilometers, for example. So they will say also the earthquake is somewhere around us at a distance 2,500. So we will draw a circle with a radius 2,500. So now it's better than before because we have 2 circles intersect in 2 points. So it's either point A or point B. So we need another station to ensure the location. So the third station will measure the lag time. Let's say they will measure 2 minutes. Or let's say 1 minute. 1 minute. They will go to the 1 minute here. This is the 1 minute. And they will measure the distance 500 kilometers. So they will go to and draw a circle with a radius 500 kilometers. The intersection of the 3 circles give you the epicenter of the earthquake. So at least to determine the epicenter of the earthquake, we need 3 stations. Building safe structure against the earthquakes. Of course, in Saudi Arabia, in Egypt, usually in the Arab countries, we don't have safe structure against the earthquakes because we don't have earthquakes. But in Japan, they have to take care. In Indonesia, in Philippines, in California, they have to take care of these issues because they have daily earthquakes. They change the foundation, al-asasat, of the building. They put sometimes rubber base in the foundation. قواعد مطاطية. Why do you think they put rubber base? So it can, that's right, it can absorb the vibration without causing any harm to the building. Number 2, we can use rollers, عجلات. We can use rollers under the building. So when we use rollers under the foundation of the building, what will happen? The building as one unit, it will slide to the right and to the left. So this will not harm the building. Okay, but look at this one, for example. This is an ordinary building, one that we have in our countries. Look at the joints between the poles and the slabs. بين الأعمدة والأسطح. These joints are affected greatly at a certain time. If you look deeply to these joints, you will find that it might break. Okay, and this is a problem with the earthquake. It breaks the joints between the poles and the slabs of the building and causes the destruction of the building. So using rollers, we can overcome this problem. I give you here 2 links for some videos. It shows you more details about safe structures against the earthquakes. So that's everything today. Thanks for attending this lecture. And if you have a question, please go ahead and ask.